Welcome back. So continuing from our last video, we found this new position vector function, and what it tells us is that any given time what the position is on this of the rocket. So if we look back at this graph, where the rocket is at any given time. So one of the first things we want to try to figure out is when the rocket lands. So when the rocket reaches this point right here. Well, we know that is going to deal with when the y or the j direction is 0. So going back to our formula, we know that this part right here deals with the j direction or the y direction. And if you look at that, you can tell that that is a quadratic. So we know that we can solve for t there, and that'll tell us at what times, or t's, the function would be 0, or y would be 0. So let's do that. So we can use the quadratic formula to solve this. So we would have t equals negative b, the corresponding b would be 44.757 sine of 46 degrees plus or minus the square root of b squared, 44.757 sine 46, that entire thing squared, minus 4 times the a, that would be this one right here. I'll go ahead, that is negative 16.1 if you go ahead and divide that by 2, times the c. There is no c, so it's assumed to be 0. All of this divided by 2 times the a term, which would be negative 16.1. So let's go ahead and just work this out the long way. So that means that t is going to be equal to negative 44.757 sine of 46 plus, if you go ahead, this is going to be 0, so the square root of this squared would just be itself, so 44.757 sine of 46, 2 times negative 16.1. We did that. If we divided it by 2, if you multiply it by 2, it'll just come back to be itself. Or negative 44.757 sine of 46 minus 44. Minus 44.757 sine of 46 divided by negative 32.2. Well, that just goes to 0, so that is 0. And this piece here, if you work out the math on that one, you'll get 1.9997. So t is equal to 0 and 1.9997. So what does that mean? So we go back up to the graph here. Well, when t equals 0, which is which is right here, we know that there is no y because we're on the ground. So that leaves this part over here to be the 1.997. So at t equals 1.9997, we're right here. We've hit the ground. So how has that helped us? Well, if we go back to where we started, if we take that time and fill it into the x or the I component right here, that'll tell us where the distance we traveled from 0 seconds to 1.9997 seconds, and we know that's where we hit the ground. So that'll tell us the total distance traveled of the rocket.